Today we'll talk about rational fractions. We talked about equations and factorization, and now we will talk about rational fractions. If we have a over b, we notice that b does not equal to 0. This is a condition. To let this one be defined, it should be put b does not equal to 0. For example, that means the denominator does not equal to 0. Does not equal to 0. Example, if we have 1 over x minus 1 we said is defined for x minus 1 does not equal to 0. That means x does not equal to 1. Another example, x over x plus 3 is defined for x plus 3 does not equal to 0, so x does not equal to minus 3. Third example, two x over x minus 2x minus 5 is defined for 2x minus 5 does not equal to 0, so 2x does not equal to 5, 2x or x does not equal to 5 over 2. This is the answer. We will take another things. If we have a over b plus c over d, here in this case is defined for b does not equal to 0 and c does not equal to 0. With respect to multiplication, a over b times c over d is defined for b does not equal to 0 and d does not equal to 0. With respect to division, a over b divided by c over d is defined for b does not equal to 0, c does not equal to 0 and d does not equal to 0. In first case, you notice that the denominator shouldn't be 0. The denominator shouldn't be 0. We cannot put the denominator as a 0. In first case, b and d here cannot be 0. In the second, b and d also cannot be 0. Why? Because they are denominators. Here in division, a over b divided by c over d is defined for b does not equal to 0, C does not equal to 0, and D does not equal to 0. In the second fraction, C over D, because we reverse it, we will revise it. It can be D over C. After changing the division to multiplication, it becomes D over C. So in the first case, when it is division, C over D, D does not equal to 0. In the second case, when we reverse division, change division to multiplication, it becomes D over C, then C does not equal to 0. So in this case, we put what? A does not equal to 0, C does not equal to 0, and D does not equal to 0. In the rational fractions, we have, for example, x minus 1 over 2x minus 1 or plus 1. This, in this case, is defined for the denominator does not equal to 0, which is 2x plus 1 does not equal to 0. We write so 2x does not equal to minus 1, so 2x does not x does not equal to minus 1 over 2. Say we take the plus 1 to the left side, to the right side, change the sign, same as equation, same as equality, but here we put does not equal, does not equal. Okay, so x does not equal to minus 1 over 2. If we have another rational fractions, if we have, for example, f of x equal 2x minus 1 over 2x minus 1 into x plus 3, we can say here f of x is defined for 2x minus 1 into x plus 3 does not equal to 0. We take denominator. We take denominator. Here denominator shouldn't be equal to 0. Shouldn't be equal to 0. So we will write 2x minus 1 plus into x plus 3 does not equal to 0. So here 2x minus 1 does not equal to 0, and x plus 3 does not equal to 0. It becomes so does not equal to 1, x does not equal 1 over 2, x does not equal to minus 3, and here we put and. So I can write a sentence: f of x is defined for all values of x, real numbers, except the two numbers, except 1 over 2 and minus 3, except these two numbers. That means you can put instead of x any number you like, except which numbers. The minus 3, you cannot put minus 3 instead of x, and we cannot put half or 1 over 2 instead of x. Why? Because if we put minus 3 instead of x, the denominator becomes 0, which is wrong. It's not it's not correct. Another examples, if we have fx equal x minus 3 over 2x plus 1, 3x plus 1 into x minus 5, he will ask find the values of x if f of x is defined or exist. Define or exist. Here in this case, denominator, we take denominator does not equal to 0. That means x 3x plus 1 into x minus 5 does not equal to 0. Does not equal to 0. First, we take the first parenthesis plus 1 does not equal to 0, and we put and x minus 5 does not equal to 0. In this case, we put between the two parentheses or the two expressions here 3x plus 1 does not equal to 0 and x minus 1 does not equal to 0. We put and, not or. In the equation we put or, but here in this case we put and. We cannot put what? Or. If you put or, it will be wrong. Okay, now it becomes 3x does not equal to minus 1 and x does not equal to plus 5. That means x does not equal to minus 1 over 3. So we can write a sentence: f of x is defined for all values of x real numbers except what? Minus 1 over 3 third, minus third, 1/3, and plus 5. This is the rational function. I will give an example, another example. For example, we have f of x equal 2x minus 1 into x plus 5 over 2x minus 1 into x plus 2. First of all, he will ask you what are the values of x if f of x is defined. Second, he will ask you simplify. If we have in the numerator and denominator same parentheses, he will ask you about simplification. Third, he said to you solve f of x, for example, equal to. As this exercise, we can solve it. For example, here we for the exercise 1, the question 1, what are the values of x if f of x is defined? We took the denominator 2x minus 1 into x plus 2 does not equal to 0, 2x minus 1 does not equal to 0, and x plus 2 does not equal to 0. It becomes 2x minus 1 does not equal 2x does not equal to 1, x does not equal to 1 over 2. And we put x does not equal to minus 2 with respect to this one. X does not equal to minus 2. So I can write f of x is defined for all values of x real numbers except half minus 2. Now here in the second question he said simplify. We can simplify after